Welcome to the Zero Sum Mathematics YouTube channel. 0.9 repeating equals 1. That equation has started more arguments on the internet than almost any other line in mathematics, and today we're going to prove it 4 different ways. Before we dive into the proofs, let's sit with the discomfort for a second. Your gut probably says 0.9 repeating is close to 1, but it never quite gets there. Think about the number line. Here's 0.9. Now 0.99. Every 9 we add, we get closer. 0.9999, 0.9999. The dot is sliding toward 1. But here's the key insight. 0.9 repeating, with infinitely many 9s, doesn't stop. It never takes a breath. It is the limit of that process, and that limit is exactly 1. Let's prove it. Proof 1 is the one most people see first, and it's delightfully sneaky. Call our number x. So x equals 0.9 repeating. Now multiply both sides by 10. 10x equals 9.9 repeating. Notice what happened. The infinite tail of 9s didn't change. It's still infinitely long. We just shifted the decimal one place to the right. Now subtract the first equation from the second. 10 x minus x, and 9.9 repeating minus 0.9 repeating. The infinite decimals cancel completely. We're left with 9x equals 9. Divide both sides by 9. X equals 1. But we defined x as 0.999 repeating. So 0.9 repeating equals 1. Clean. 3 lines of algebra. Done. Proof 2 is perhaps the most immediately convincing if you're a visual thinker. 1/3. In decimal, that's 0.3 repeating infinitely. Most people are totally comfortable with this. Now multiply both sides by 3. On the left, 3 times 1/3 is 1. That's just arithmetic. On the right, 3 times 0.3 repeating is 0.9 repeating. So 1 equals 0.9 repeating. That's it. Barely 5 seconds of math. The only assumption is one you already believe, that 1/3 can be written as 0.3 repeating. Proof 3 is where things get properly satisfying from a calculus point of view. Let's write 0.9 repeating as an explicit sum. 9/10 plus 9/100 plus 9/1000, and so on. In sigma notation, that's the sum from n equals 1 to infinity of 9 over 10 to the n, which we can factor as 9 times the sum of 1/10 to the power n. This is a geometric series. The formula for the sum of an infinite geometric series is a times or divided by 1 minus r, as long as the common ratio r is strictly between -1 and 1. Our first term is 9/10, and our ratio is 1/10. 1/10 is definitely less than 1, so the formula applies. Plugging in, 9 times 1/10 in the numerator, 1 minus 1/10 in the denominator. 9/10 divided by 9/10 equals 1. The infinite sum converges perfectly to 1. No rounding, no approximation. The series lands exactly on 1. Our fourth proof is the one a real analyst would insist on, the formal definition of what an infinite decimal actually means, because infinitely many 9s isn't itself a number. It's a notation for a process, a limit. S sub 1 is 0.9. S sub 2 is 0.99. S sub 3 is 0.999. Each term gets closer to 1, but never crosses it. That's fine, because we're asking what happens when n grows without bound. The limit as n approaches infinity of S sub n equals the limit of 1 minus 1 over 10 to the n. As n goes to infinity, 10 to the n blows up, so 1 over 10 to the n shrinks to 0. 1 minus 0 equals 1. By definition, the value of 0.9 repeating is this limit, and this limit is exactly 1. This is why mathematicians say the two numbers are not approaching each other. They are the same number, expressed 2 different ways. 4 proofs. 4 completely different branches of mathematics. Algebra, fractions, infinite series, formal limits, and every single one of them arrives at the same conclusion. 0.9 repeating does not fall just short of 1. It is not rounding. It is not an approximation. It equals 1. Exactly. By definition, the discomfort you feel is intuition, bumping up against infinity, and infinity plays by different rules. Thanks for watching.